Now let's see another problem, and this problem relates to arithmetic progression and finding the volume of a solid body. So volume of a cuboid essentially. So what does this example say? It says that there is a small terrace at a football ground that comprises of 15 steps. So there is a terrace that has 15 steps and each of the step is 50 meters long and is built of solid concrete. So it is made up of concrete and it is 50 meters long. Each of the steps is 50 meters long and each step has a rise of 1/4 meter and a tread of 1/2 meters. So we have to calculate the volume of concrete that will be needed to build this terrace. Let's have a look at how the terrace steps would look like. It said that each of the steps would be 50 meters in length. So this length for each step would be 50 meters. It has a rise of 1/4 meter, right? It has a rise of 1/4 meter and tread is this. The width of the step is called the tread and the tread is given to be half meters. So for the first step that we have, what would be the volume? What would be the volume of the first step would be? Volume of first step, it will be a cuboid, right? You have length, breadth and height and you have a solid structure, so it's a cuboid and the volume of a cuboid is length into breadth into height. If you have not studied it yet, the volume of a cuboid is length into breadth into height. What is the length? We have 50 meters into half meter into 1/4 meter, which is equal to 25/4 meter cube. So the first step's volume would be 25/4 meter cube. What will be the volume of second step? The second step is this, right? This is the first step that we have found the volume of. The second step would be this, and there will be a supporting step that will be right beneath it, right, which will be equal to the same. So you have to take 2 times the volume of this step. So the volume of the second step would be 2 into 25/4, 50/4 meter cube. The volume of third step. Now this is the second step that we have taken. The third step would be 1, the second supporting structure and the third one, because you have to make it completely solid. So there will be 3 steps of equal volume kept one above the other to form the third step. So the complete volume of the third step would be how much? 3 into 25/4, that is equal to 75/4 meter cube, and so on. Just see the difference between each of these steps. 50/4 minus 25/4 would give you 25/4. Similarly, 75/4 minus 50/4 is going to give you 25/4. So the volume of each step essentially forms an AP. The series, the sequence of each step, the volume of each step would form an AP, with the first term being 25/4 and the common difference being 25/4. Now we have to calculate the volume of the entire terrace steps. So what would that entire sequence will be? The total volume would be Sn, which will be S15 because there are 15 steps, and it will be equal to the volume of the first step plus volume of the second step, volume of the third step, so on till 15 steps. Now here we have A equal to 25/4, we have D equal to 25/4. Now we can use the formula for Sn is equal to n/2, 2A plus n minus 1 into D, which is 15/2, 2 into 25/4 plus 15 minus 1 would be 14 into 25/4. 4 because the common difference is also 25 by 4. We have 15 by 2, 25 by 4 would be common, and what you get is 2 plus 14, right? Now you have 15 into 25 into 16 by 8. You cancel these out, you get 15 into 15. So the volume of concrete will be equal to Sn, and it is equal to 750 meter. This is how you obtain the value of the entire volume of the concrete terrace that we are going to make. What did we do in this? The terrace comprises of steps, and each step will have a volume equal to L into B into H. Now for the first step you just have to consider this portion. For the second step you have this structure and a similar structure that we place just beneath it so that the steps do not fall. It's a complete solid structure, okay, so it's not going to be hollow. The third step will have 3 similar slabs of cuboid placed one over the other. The fourth step will have 4 such slabs put up together. Similarly, you will have 15 such steps. Volume of the first step will be L into B into H, which is the volume of the cuboid. We have length as 50 meters, the breadth as half meter, and the height is 1 by 4 meter for each step. So we have the volume of each step as 25 by 4. For the second step it becomes 2 into 25 by 4 because, as I said, there are 2 similar structures, 2 similar slabs that will make up this step. For the third step we have 3 into 25 by 4 and so on. And we observe that the volume of each step would form an arithmetic progression with a common difference equal to 25 by 4 and the first term being equal to 25 by 4. Now we have to calculate S15, which is the volume of concrete that makes up the 15 steps. We use the formula Sn equal to n by 2, 2a plus n minus 1 into d, where n equal to 15 as the number of steps is 15. We substitute the values and in the end we get the volume of concrete to be equal to 750 meter cube. I hope you understood this question. Now let's go to another question, and I hope you are now getting the whole concept of arithmetic progression clear in your head, and that's why we are pulling in complex questions with different mixed concepts of different chapters, because starting from this year the board exams are going to cover the entire book. So all the chapters that you study right from the chapter 1 to the last chapter that you have will be asked. Hence there is quite a possibility that some questions that cover mixed concepts will also be asked. So now let's go to the next question, which will be the illustration number 33. Now in this question we have a spiral that is made of successive semicircles with centers alternating at A and B, with the first semicircle's radius being 0.5, the second one being 1 centimeters, the third being 1.5, and so on. We have to find the total length of the spiral that is made of 13 consecutive semicircles. Now the question is a bit complicated. Let us try to understand it using this figure. So we have 2 points A and B, and we have to start making semicircles first with the center being at A, then the second semicircle center being at B, the third semicircle center being at A again, the fourth semicircle being centered at B, and so on till we obtain 13 such semicircles. And then we have to find the length of all the spirals up to the 13th semicircle. So now we keep the center at A, which is the requirement for the first semicircle, and we take the radius as R1. R1 will be 0.5. We start with 0.5 centimeters. So with the radius at 0.5 we make a semicircle. After making a semicircle, we change the center from A to B and we increase the radius from 0.5 to 1. So this was 0.5, this was 0.5, this was 0.5. So from B, if we draw a semicircle of radius 1, it will be here, right? So you get a spiral like this. When you reach here, you again shift the center to point A and you have to take the radius as 1.5. Now this is 0.5, this is again 0.5. So you have, this is 1 because this point is 1. The second semicircle's radius was 1. So this will be 1 and this will be 0.5. So this will be 1.5 and you create a semicircle. Again you change the center to B. This is 1, this is 1. So you have a complete semicircle with radius 2. So you go on making it. So let's see what the spiral length would be. Let us take the length of the spiral 1. Let L1 be the length of the first spiral. Length of first spiral. And what will it be equal to? It's a semicircle. So the circumference of a semicircle is pi into R1. And what is R1? R1 is 0.5 because the radius of the first semicircle is 0.5. L2 is equal to length of second spiral. What would be the length of second spiral? It will again be pi into R2. And what is R2? It's 1. Pi into 1. Similarly, you can obtain L3 as pi into 1.5. L13 would be pi into, this is how much? 3, 15, 13 into, because each time you go on adding 0.5. So first spiral it's 0.5, for the second it's 2 into 1.5, for the third spiral it's 3 into 1.5, 3 into 0.5. So for the 13th spiral it will be 13 into 0.5. Now we have to find the total length of the spiral. So we have to find S13, which will be equal to L1 plus L2 plus L13, which is equal to pi into 0.5, pi into 1 plus pi into 13 into 0.5. You take out pi to be common. You again have an AP. You have an AP whose first term is 0.5 and the common difference is 0.5, and you have the last term also known. Last term is 13 into 0.5. So you use the formula, number of terms is 13. So n by 2, A plus L. A is 0.5 and the last term is 13 into 0.5. So you obtain 13 by 2 and this will be 14 into 0.5. You have 91 into. So you have the length of a spiral for 13 consecutive semicircles equal to 49.5 centimeters. Oh, we forgot the pi value here. So we have S13 equal to, you have to multiply it. You have to multiply it with 22 by 7. We skipped this. We calculated the sum of 13 terms here. We skipped this pi, and pi is given to be 22 by 7. So we will have to multiply it with 22 by 7 also. So here you have 22 by 7. So you have 13. So you have how much? 22 into 5 will be 11. 122 into 5 is 110, and you have a point. So you have 11 into 13, which is equal to 143 centimeters. So this is the final value that you get. So the length of spiral 13 made up of 13 consecutive semicircles would be 143 centimeters.